Dear students, welcome back. Introduction to Quantum Technologies and Applications. Today, we'll discuss Module 2, the theoretical structure of quantum information systems. Here, in this module, we'll study qubits, conceptual understanding, classical bits versus quantum bits. Third one, quantum systems, trapped ions, superconducting qubits, photons. Fourth one, quantum coherence and decoherence. Fifth one, theoretical concepts, interpreted abstractly, Hilbert spaces, quantum states and operators. Sixth one, the role of entanglement and known locality. And seventh one, quantum information versus classical information. And eighth one, philosophical implications, randomness, determinism, observer role. Now, what is qubit? The conceptual understanding using spin and polarization. Quantum information systems represent a transformative approach to computation and communication, fundamentally leveraging the principles of quantum mechanics to process and transmit information. Quantum information system is mainly divided into the quantum information science has divided into three types. First one is quantum communication, quantum networking, quantum cryptography. Second one is quantum computing. Quantum computing is having analog quantum computers, digital quantum computers. Analog quantum computers further divide into adiabatic quantum computing, quantum annealing, quantum simulation. Digital quantum computers are gate based quantum computers, quantum machine learning. And third type is quantum sensing, quantum system design and development. The quantum information science branches into three major fields we have seen in our blog track. Quantum communication includes quantum networking and quantum cryptography. Quantum computing, it has divided into analog computing and digital quantum computers. Um, Similarly, quantum sensing focus on quantum system design and development. Theoretical foundation of quantum information systems. The theoretical foundations of quantum information systems contains the superposition allows quantum systems to perform parallel computations, offering exponential speedups for certain class of problems. The theoretical foundation of quantum information systems are: number one, quantum mechanics. The core principles such as wave function, unitary evolution, and measurement theory form the basis for information processing in quantum systems. Second one is qubits and quantum gates, which are analogous to classical logic gates. Quantum gates manipulates qubits using unitary operations, enabling the construction of quantum circuits. Third one is quantum entanglement, a uniquely quantum phenomena where the states of two or more qubits become interdependent regardless of spatial separation, enabling powerful communication and computation protocols. Fourth one, quantum algorithms and complexity. Algorithms such as Shor's for factoring and Grover's for such illustrates the advantage of quantum computing over classical approaches. Fifth one is quantum error correction. Due to the fragile nature of qubits, and error correction techniques are essential for practical and scalable quantum computers. Quantum communications protocols like quantum teleportation and quantum key distribution exploit quantum entanglement and superposition to enable the quantum information transfer. What is a qubit? Qubit or quantum bit is the fundamental unit of information in a quantum computer. A qubit can exist in a superposition of both states simultaneously. It is represented as a ket 0 and ket 1 or any complex linear combination of alpha ket 0 plus beta ket 1, where alpha and beta are complex probability amplitudes. The Boole sphere, the Bloch sphere, is often used to visually represent a qubit state where the poles corresponding to ket 0 and ket 1 and any point on the sphere surface represent a superposition. This superposition allows quantum systems to process vast amounts of information in parallel, enabling certain computations to be executed exponentially faster than their classical counterparts. Qubits can also exhibit entanglement, a uniquely quantum phenomena where the state of one qubit is dependent on the state of another, regardless of the distance between them. Various physical systems can be used to realize qubits, including superconducting circuits used by IBM and Google, trapped ions, IonQ, photons, psi quantum, quantum dots, and NV nitrogen vacancy centers in diamonds. Each technology comes with trade-offs in terms of gate speed, error rates, scalability, and environmental requirements. Now, superconducting circuits. These are fabricated using superconducting materials to create circuits that behave mechanically at very low temperatures. Major companies like IBM and Google use superconducting qubits for their scalable quantum processors. They offer relatively fast gate times and integration with existing semiconductor technologies. Trapped ions. Individual ions are confined and manipulated using electromagnetic fields in vacuum chambers. IonQ is a leading company leveraging trapped ion qubits, which typically exhibit very long coherence times and high fidelity operations, making them exactly for precise quantum computations. Photons. Quantum information is encoded in photons, properties such as polarization or path. Psi quantum uses photonic qubits which excel in low decoherence and connectivity over long distances. Advantages for quantum communication and scalable architectures. Quantum dots. These are semiconductor nanostructures that confine electrons or holes with discrete energy levels acting as qubits. They offer potential for integration with existing semiconductor fabrication and exhibits tunable quantum properties. Last one is a nitrogen vacancy centers in diamond. These are the diamonds where a nitrogen atom and a vacancy forms a system which is having the quantum states. NV centers are notable for long coherence times at room temperatures, optical addressability useful for sensing and quantum information tasks. Okay, these nitrogen vacancy centers in diamonds, recently they are used in uh, Iran war. This is a ghost whisper, the technology which is used to uh, capture a magnetic field coming from a soldier, but from a distance 50 kilometers, they identified the magnetic field coming from the soldier and they identify they rescued that person.